Good. So, hello everybody. Good afternoon. Welcome to my talk, The Future of Frontend Development. My name is Hahnekamp. I actually have a kind of a Dutch-sounding last name, I think, but I come from Austria, as you can probably hear from my accent. So I'm working for Angular Architects, so we are more or less in the Angular business, as the name, of course, says. I'm curious, who of you is using Angular? Oh, the majority. Good. Then you're in for a disappointment because you will not hear so much about Angular, only in the end. But it's more about front-end development in general. But please stay. Not that everybody's now leaving. No. For us, of course, it's very important that we understand what's going on in the industry of front-end development. It's crucial. And I would say based on research numbers, but also with discussions with colleagues, going to companies, and also if we take a look at what the current new frameworks are working on, what features they are trying to implement, I try to come up with some kind of prediction how the future of front-end development will or could look like. And as you've seen, the subtitle was Back to the Future. I'm not going to explain what this is all about, but I'm quite sure if I'm finished with my talk, you will all mean what I mean by that. Good. This is how we will do it. So first of all, if we want to take a look into the future, we need to, of course, know where we came from, what is the current status, and then this is actually all about the trends that we see currently. Run faster, run less. I will explain it when we are there, but especially in the run less our code. So this would be 3.b. I will show also some live coding of the latest frameworks. Then in the end, also a little bit of a personal assessment or my personal opinion, a summary, and then hopefully we also have enough time for Q&A. Good. So as I said, past and present, don't want to start from the very beginning, but at least JavaScript was kind of birth of JavaScript in 1996. You could say, or we hear this quite often, that people say this was not the brightest moment in the history of programming languages. But we have to be fair with JavaScript a little bit, because JavaScript was meant to be a scripting language. The job or the programming language that was meant to become the language for programming web applications was actually Java, but for some reasons it didn't work out so well, and that's why JavaScript was the only language that survived. And well, we need to find a way how to deal with it. Then quite some years later, we had this term Ajax, and this was really a milestone in the history, because with Ajax, it was a common technology, a very popular technology, or a pattern where we can say we can load something from a backend, an HTTP request, without reloading our complete page. And this is actually where JavaScript proved itself that it might be possible to write real web applications, single-page applications with JavaScript. And then very in the beginning, in this ignition point, so to say, quite a lot of frameworks, libraries were released. So we had, for example, Prototype, we had Dojo, and then came jQuery, and many more. And what this slide should show you is that if you've been working at the time on a particular JavaScript application, you were always afraid that you can rewrite your whole application in a few months, because then you knew that a new framework will be released, and then you have to switch over. And I think that this is still something where JavaScript or the industry has a very bad reputation, but it's not entirely true anymore, because it has changed with the release of 3 major frameworks that we are still using, or that majority is still using. The first of that was Angular, AngularJS, but I would see it here as one thing together. Then we had React, and right after React we had Vue. And if we zoom in, then we have to say that since then, so since the release of Vue, it was more or less, we can speak of a matured industry, I would say. So it was not the case that you were, or that you had to be afraid that you need to rewrite your application every month. And the question, of course, is now, will it stay, or is this going to change? And for me, at the moment, the situation looks kind of like this, where we have a very similar situation in sports, in tennis, for example. So if you know a little bit of tennis, then you know these three guys. They are called the Big Three, and they have been dominating that sport for decades. It's not that there were no new players, so very similar to JavaScript frameworks. There were quite a lot of new players who want to become or beat them, but they were just so good and also found their ways how to adapt to all these latest trends and really assimilate it so that they can really more or less stay on top of their game or on top of the framework world, more to say. And this is what we see at the moment. But we also have to say there is again now this trend, maybe started last year, but now it becomes more and more obvious that something is going to change, and this is of course now what I want to show you. If you take a look at all of these changes, you can kind of say it's in a way always comes down to it's all about speed. So everybody wants to be fast. Everybody's talking about speed. We want to have faster execution. And if you look at this, how can you improve speed? There are more or less two options you have. You can just run faster, or you can just run less. Run less means I find a shortcut, or I don't have so much code I need to run in order to fulfill my targets. And when we take a look at run faster, so I think that there is not so much we can expect in that area. It comes more or less from the other one. But let's just take a quick look at it. So we could say, well, JavaScript, can we run JavaScript faster? Is there a better language we can use instead of JavaScript? And here I would say, not really. So when we are talking about web applications, we have WebAssembly for some time. In the very beginning of WebAssembly, people said, or some people said, that this is a candidate which might replace JavaScript. Other people also said, no, that's not the idea of WebAssembly. It is not there to replace JavaScript. It's just there that you can write, or that you can just use some applications that have been written in a different language and then port it some way to the web itself, because the browsers can natively execute WebAssembly. And this is what we see. So it's definitely not the case that WebAssembly will replace JavaScript. Definitely not. Then we see something else. We see quite a heavy usage of languages like Go and Rust lately, also in the tooling actually. So we see that many tools are rewritten in one of these two languages that former have been written with JavaScript. And this is a trend, because the reason why we do this is that we say, well, it just runs faster. And we see this, for example, at the moment. So very popular tools are ESLint. We also see it with Vite. We also see it with VTest. So these are all tools that run extremely faster just by not using JavaScript to write them. But this doesn't mean that we can use Go and Rust in our web applications in the browser. Their JavaScript will still stay. But when it comes to the tooling, we can expect that more and more tools will be ported to Go or to Rust, and then be executed natively. This is actually also something that Angular is looking at the moment. Angular, for example, is forever using Webpack, which is written in JavaScript, and now they're looking into ways how to integrate it with ESLint. Vite, for example, comes from Vue. It's already there for quite some time. So this is about the language itself. Can we improve the engine? Well, I mean, you could, but I think it's over. So we have kind of reached a point where I say we can't expect any significant improvements anymore. Why? Because most of the browsers are now running on Chromium, which is backed by V8. V8 is the engine, and they have invested quite a lot amount of time in order to come up with this performant JavaScript engine. But this is already a very long time ago. So the browser wars has actually been won by the Chromium-based browser. There is no real competition out there anymore. So I think that the pressure to even improve V8 even further is not that large as it used to be. Maybe this changes. We have seen 1 or 2 months ago the release of Bun. I hope I pronounced this correctly. Bun is actually something like Dino or Node.js, so JavaScript you can run on the server, but it runs with JavaScript core. So this is the engine it uses behind. It's much faster. I've never tried it out, but this is at least from the benchmarks what we hear, and it's also the engine that powers more or less Safari. We will see, but yeah, I don't really think that it will have a huge impact. And I will also say the same is true when we're talking about the rendering. Yeah, you can always improve it, but the significant changes that really might have an impact to the future, how we will develop or what tools we will use to develop our applications in the future, there will be not such a huge impact. And this leads me to the actual one: run less code. We can run less, which means we can kind of try to come up with a framework that hasn't so much code, or we can also try to minimize our code, as I've said in the beginning. If we're looking at the possibilities that a framework has to reduce its amount of code, there is a very, very interesting approach. Let's just say we have a web application. Let's just say the user clicks on something, and then the way how it's normally done is that inside of our browser we have our JavaScript framework. The JavaScript framework has an event listener to the DOM event. It checks our source code, it interprets our source code in order to find out what we want to do with this event. Then something happens, and in this case, now we are recreating a new DOM element. That's the way, very on a very abstract level, how it is done. Of course, the interpretation phase takes some time, and this is the major disadvantage. The frameworks themselves, they are quite often much larger than our actual source code. And if we can minimize that part, then of course we would have a significant performance improvement or benefit. And you see here the word interpret. So this is there on purpose, because if you switch the perspective a little bit and you see the framework, like you say, well, maybe this is a runtime or an interpreter of our code, then you can take a look at solutions that have already solved this problem in the past. So if we say it's an interpreter, we know if we want to improve this from a programming perspective, and everything that we need to do is that we need to come up with a compiler. So if we could find a way that we can compile our source code in a way that we don't need to load the interpreter or the framework into the browser, then we would, of course, win quite a lot. And just to give you here an example how this could look like from a pseudocode, in the end, all the frameworks that we are using, or the big three, they have this abstraction layer where they demand from us, yes, we are component-based. You need to define whatever you want in the form of a component. This is the way how I want it. And during the runtime, I can interpret this. Of course, I need also some kind of abstraction level on my own for the DOM. In React, this would be the virtual DOM. In Angular, we have something different. But there is quite a lot of overhead which is required for that. And in the end, if we have a tool that can compile the code to say, well, you don't need to define it in the structure that the frameworks need, you just write document create element button at an event listener, and that's it. Then you don't need to interpret anything anymore. And of course, you don't need to have the framework inside of your browser anymore. And this is exactly what we actually have for several years now. And the most popular framework for this is Svelte. So Svelte does exactly do this. It's a kind of a zero bundle framework, and it completely removes itself because it's only required during the compilation. Yes, some code is also a little bit on the browser or in the browser, but compared to the rest what we have so far, it's nothing. So we really see that with this compilation approach, we end up with quite a smaller bundle size, significantly smaller bundle size. And then, of course, this improves the performance as well. Angular also has a compiler. React is working on a compiler, but they are not to that extent as the Svelte compiler where Angular says, okay, I'm completely eliminating myself during the build time. That's not the case. The compilers, they are just producing the code a little bit. They are I don't want to say reformat, but they print out a structure that is optimized for the interpreter, for the framework just to be executed. That's what these compilers are doing in the end. Yeah, so we will see. Svelte is already there for quite a lot of time. Some even say it's the fourth candidate, so that we even speak of the big four by now, but there is something more happening at the moment. And this is run less and reduce our code. And this is where I see that the most innovation currently is going on. And it's also the most excited one. Basically, we do this already for more or less always. So we have the server-side rendering technology. So I have my framework. I run it on the server side. The framework produces me HTML, CSS. I send this part to my client. Then I have the static version. So the users are looking what they can click on. And in the meantime, on the server, I'm sending my JavaScript bundle, and then the page actually becomes interactive. If the users click on something before it becomes interactive, we need to have some kind of maybe minimal JavaScript that can record all these events. This is, for example, how it is done in Angular. So this is not nothing new. But the major innovations, they are taking place in the area of this hydration phase. How and when do we send JavaScript to the browser? And you see already when I say the major innovations are happening in the hydration, when you have server-side rendering, you need some kind of backend that is also able to process JavaScript. So this is one of the major key findings here. So what can we do in order to improve this hydration phase? We can do code splitting. Also, not something very new. You just pick one criteria and you say, okay, I have this huge amount of application, amount of source code. I just split it into multiple pieces. And when I say, okay, this is the router, it just I know exactly what elements are required inside of this router, what parts of my application are required inside of my router, and then I just send these parts to the browser, and that's more or less it. So it's a common technique, not something very new. What's new is that we could do the data fetching on the server. We'll explain it later. We could also say, maybe we don't need to hydrate everything, especially if this is a component which is non-interactive. So why do I need to come up with JavaScript when my users can't do anything with it? And the most demanding or the most challenging one, on-demand hydration. So the framework finds some ways when the user clicks on something that the framework knows exactly what JavaScript needs to be loaded. And this is not based on a criteria like the route or like something, but just the framework knows this click is triggering this process, and I need to have these and those dependencies. And this is all done by the framework automatically. We don't have to do anything else. This is the most advanced that we currently have, most advanced technique. And I want to go through all of them now. So maybe about the technologies that I'm going to show you. I said you will not see that much Angular. This is what you will see instead. So I will use Next, Quick, and also React Server components for this. If we start with the classic hydration, this is a different drawing so that we have a common drawing through all the patterns. We say, yes, the static HTML, this is what I've just shown you, comes with the first request. Then our app becomes interactive. The JavaScript is sent out to the client. It's fully activated, our application. And if we have user actions, we don't need to do anything between like sending some other JavaScript to the browser. It's not necessary anymore because the application is fully loaded. This is common technique. With data fetching on the server, we say, okay, maybe we don't need to do all the processing, all the loading, all the mapping to the data structures that we need on our browser. Maybe we don't need it in the browser. Maybe the server can do it for us, and the server is just sending us exactly the data that we require at this very moment in time in this exact structure. And this is what data fetching is all about. Data fetching on the server is all about. So when the app becomes interactive, we are not sending the complete bundle to the browser, but we say we keep our JavaScript, which is responsible to fetch the data on the server. We only deploy or publish the rest of the application, and the server, as we will see, has its way to send the loaded data to the client, and the client just gets it and doesn't have to care about anything else. And of course, if the app then becomes interactive, so when the user, if they're triggering some further actions, we always have this data fetching logic on the server, and we don't have to do anything about this on the client. And the two frameworks at the moment that are really doing this quite a good way, or a very popular one, are Next.js and Remix. Both are based on React, unfortunately not on Angular. There are some bindings for Remix, for Angular. I've never tried them out. But yeah, Next.js is more or less comes from Versal, a very huge company in the React space, and Remix is something which kind of tries to do the same thing as Next.js, but just better. They were very hyped in the first half of this year. Now, I think the hype goes down a little bit, and that's why I'm showing you Next.js and not Remix. So, great. My IntelliJ has frozen. No, there we have it. So I have here an application. This is, let me close this. You see, it's not doing that much. It is just listening some kind of posts. It's also interactive. I can click on edit, then something's happening. And as you also see here in the web dev tools, there are some requests to the backend. So we are requesting here the episodes. So let me check if I can zoom in here a little bit. Yeah. The key thing, please remember this is non-optimized. It has 9 megabyte. Again, this is not optimized. It becomes much smaller when we run the build on it. But let's just keep it for now. Let's say we have 9 megabyte. If we take a look at the source code, then we see this is how it is done in React. In Angular, it would look a little bit different. But we say here we use the fetch, so no HTTP client. We are fetching something from the endpoint. And then we have here this parse episode method. And what this method is doing is that, first of all, it uses a library which is called sort. So this sort is a library which we can use in order to have type safety during the runtime. So it really does validation of the types during the runtime, a very important library. And the content that you have seen before is all written in Markdown. And that's why why this parse episode method here is also transforming the Markdown into HTML, which we see here from Remark in Remark HTML. So quite a lot of stuff is going on here just for fetching the data and preparing it. And with this new framework, so with Next or with Remax, what you can do is that you say, okay, in the same source code, I just say get server-side props. This is a function. No, it's British. Get server-side props. It's actually an async function. And what I can do now with this function is that I can more or less do the complete fetching here in this function. So I just copy this, only these lines. Okay. I say I'm getting here my episodes back. Of course, I need to await this. I can do this. And then at the end, I just say I want to return. There is now, of course, I need to stick to the convention. I need to put the episode into this props. And my component that gets the data can now say, okay, I want to have these properties. So I say here I have some props. And in order to get the type, there is this infer get server side props. So I can say get type, get type of the get server sides props like this. And then I actually can get rid of all that stuff, because when the component is rendered, the episodes are already there. I don't need to do anything more. So I just need to say here, I'm passing on the episodes now to the children components, and that's more or less it from a developer's perspective. In the back here, the backend of course knows now whenever I need to render, whenever the router requests this particular page where this component is required, before I render the component, I run all this code on the backend. And then I just send it to the component. The component doesn't have to deal with in the way how it gets the data. It's just there. Unless I didn't make a mistake. Yeah, of course I did. Let me quickly check. Nope. This looks nice, actually. Oh, okay. It's working now. And you see the difference. From 9.1 megabyte, we went down to 6.7. We don't have these episodes request anymore. And that's just because all this heavy stuff is done on the server itself. And of course, I could reload this route quite many times. I don't have to deal with the loading anymore on the client. It's all done on the server. So this is a huge improvement, not just in bundle size, but also in terms of speed. When I first heard this approach, I said, well, I don't see here really the benefit, because in the end, this is just an API request. I can do this also in Spring or whatever I use in the backend. I can do more or less the same thing. But what we see in reality is that the APIs are not optimized for a frontend for different reasons. Maybe they send too much data, maybe they send data which needs to be mapped. Let's not forget about the type validation. And if you can do this with the front-end technology, then of course you gain quite a lot. If you're familiar with this term backend for front-ends, this is exactly what we are doing here, but just baked into the framework, and we don't need to use any special other library or this. Of course, if the fetching is done on the server, let's not forget, if our API is sending more data than we actually need, this is also faster, because the server fetching sits next to the database maybe, or it's very close to it. So the fetching is faster. If we need to fetch from multiple resources, then of course it's also a little bit faster. And yes, you could do this with normal APIs, but what you cannot do, and this is what, for example, Remix made very popular, when you have these kind of nested routes where you say, okay, I'm not just loading one component, I'm loading multiple components, and all of these components need to fetch the data in some way, then there is a logic involved, because the framework knows of all the different fetches that need to be done and can run them in parallel. And it can do this ad hoc. So you don't need to always go to the backend team and say, okay, now we've changed the front end a little bit. Please, can you update it so that it's now returning this or that stuff? No, you can do whatever you want. You're in full control as a front-end developer. As long as the data is there in some way, you can fetch them in a very performant way. Good. So this is the data fetching part. I have listed here some libraries that you usually see in this area. Let's not forget GraphQL client, OpenAPI client. Some people even use state management only for caching purposes. This would also reduce it here a little bit. And as you've seen, Markdown, sort. So these are quite some huge dependencies here. If we want to extend this idea that we leave some parts on the server, it's just natural that we say, okay, maybe the data fetching can be done on the server, but also, as I've said before, we have some components where I know I don't need them, and I don't need to render them anymore when they are already server-side rendered, because there is no button, there is no possibility to click on something. They are not interactive. So why do I have to send all the JavaScript for this component to the server, to the client? And this is what these non-interactive components on the server's approach actually does. It can, of course, also do the data fetching, but in addition, we can also say, I have these bunch of components, I will never need them to be interactive on the client, just leave it on the server. And then, of course, our bundle size reduces significantly, depending on the application that you have. And, well, when user interactions continue, it's just more or less the same. And what frameworks do we have that can do this? There is one very popular one, which is React, and the other one is Astro. So React Server Components, this is the technology. React is working on this already for some years. It was planned to be available with React 18, but still not there. But it's in a beta version, and we can already take a look at it. And Astro is something I will explain later. But first, let's take a look at the React Server Components, how they work. So I have more or less written the same page in React Server Components, which means I need to change the port, 4000. And you see here more or less the same thing that we have seen before. So there is an episode request. It's just 2.7 megabytes. It's a different framework, so don't compare it with Next.js. And what we also see, and this is very important to remember, in the console log, there are some outputs coming from the components. And if we take a look at our application, well, I have to say all the markdown, all the image here, everything, this is just static HTML. There is no interactivity. The only interactivity that I really need is when I click on the edit or on the more info button, because then something happens. But for the markdown component, I don't need such a thing. And wonderful, wonderful. I'm a new Mac user. They said I should use it, and it's just much more stable than any Windows machine. But I'm always scared that it's not working. Good. So we have here React Server components. Let's do this quickly. So in my source, you see how it looks like. These are the components. And with React Server components, we can add the term server to the file name of the component. And if I do this, then I'm telling React, look, this is a component I want you to render only on the server. Of course, send the static HTML to the client, but don't send the JavaScript for this component to the client. And at the moment, the app server component is calling the overview client component. And this, as the name says, this is clearly a component only, which is only sent to the client and is only rendered on the client. And here we see the code that we have seen before with use effect to fetch the episodes. There are also some other components there that don't have a server or a client. This means there are some kind of shared components. They can be used for server components, but also for client components. And you see here the console log somewhere. Here it is, fetch data. The overview client is calling the episodes are calling the episode card, and the episode card is using a markdown component, which kind of has all the logic for transforming the markdown into HTML in the component source code and here. So it's not that what we've seen before, that the parser is doing this, but here we have a component which is responsible for that. There actually exists a React Markdown component which makes sure that there is no dangerous HTML present. So it's a good idea to use something like that. And here we see console log running Markdown. And this comes from these, so we see this here, these are the three outputs. So the only thing that I need to do when I say, okay, actually the complete DOM tree, I don't need to render the complete DOM tree, everything is just static. And the only thing I need to do is that I say, okay, here we have the overview client. So if you see the application from the perspective of the DOM tree, you would say the app component runs on the server, and then already it breaks more or less because the overview client is the direct child, and it says I'm running on the client, and all its children are then also running on the client. So if I change the overview client to overview server, this would mean that the complete DOM tree would be rendered only on the server, and I don't need to do anything more. I don't need to publish anything more to the client except my client components. That's for sure. But the logic, again, to fetch, to validate the types via sort, the markdown component with all its huge dependencies, this is now all a server component. So I say here, okay, overview server.js. And there is actually a library from React for the fetching because I need to do this synchronously. It's called fetch React. Yes. So I say fetch, paste it here. So I do this directly in the component. There is no get server-side props or something. I say this is the response that I get. I call JSON. And then I need to, of course, also use the parse episode because there is some const episodes where I say, okay, the response, I map it and call the parse episode. And the rest can already be deleted, but I keep the console fetch data. Okay, this can also be removed. Otherwise, I think I'm getting some compilation errors. And episodes. Yeah. And I think that was it already. Yeah. So I'm just said, okay, I'm not canceling it anymore. Yeah, and we see the console log is gone. The network, if we go to fetch XHR, we also see that there is nothing happening anymore. We have 2.5 megabyte, but this is because it's also, again, it's a non-optimized, it's a beta version, but when it's really final, you can expect that it is much more smaller. And the question is, where are my console logs? Because I see here something, and the console logs, they are now all part of my server. So we see here fetch data running Markdown. It's all done on the server and never, ever anymore on the client. And also the JavaScript is not required. So if this comes out for React, which is not a new framework, but an existing one, yeah. This was just a comment from the perspective of an Angular developer. Okay. Good. And then we have the last one. Yeah, maybe not the last one. Island architecture with Astro, very similar. But there we have an additional framework that can consume multiple other existing single-page application frameworks. So this means we can more or less mark several regions in our application where you can say this is a static region, this is a dynamic region, and then this Astro framework will load the dynamic components based on some criteria. Could be like it's in the viewport or maybe the user is clicking on something. But in the end, it's kind of the same principle that you have seen before, with the addition that there are some criteria when the client JavaScript will be loaded. So it's not just loaded by in instant, but there are some criteria to do this. But as I said, it's another framework, and you need to use React. Angular also already exists for that. I think compared to React server components, and if we get them very soon, I don't see so much need for Astro. So that's why I haven't prepared any demo in that case, just showing the slides. But the idea of Astro, that we say we have some criteria. So again, the old things that just stay. We still have the data fetching on the server. We also have the non-dynamic or non-interactive components on the server. This is still available here. But the possibility of having a criteria when the JavaScript, the client JavaScript, should be loaded, and that it shouldn't be loaded everything, that we don't want to load all of it immediately. This idea, extended a little bit, is what I would call on-demand hydration. And this is what I said in the beginning. When the app becomes interactive, we are not loading any JavaScript. It just stays the static HTML as it is. The only thing that we do, we are loading some very small JavaScript into the app, a static JavaScript that listens to certain user events. And this JavaScript then knows when a user event happens that it needs to go back to the server, need to do the user action one, and it just sends the specific code which is only necessary to fulfill this action, and the rest stays on the server. And the more our users are interacting with it, the more we can see that more from the server is sent towards the client. And this is the best that we have at the moment. Is extremely fast, as you can imagine. And technologies that support this at the moment are Quick. Quick comes from Mishko. I don't know his last name, but he's the creator of AngularJS. And Astro a little bit. With Astro, we have to define it on our own, the dynamic areas, but with Quick, we don't. Quick does this automatically. The way how Quick works, I have also prepared it here. It runs on another port, 5 something. So you see it here. If you take a look at the network, we see 800 kilobyte. Oh, sorry. No. This make. Next time I come with my Windows machine. Good. So we have here Quick. It looks kind of the same. So the patterns that you have already learned, component-based programming, it's still the same. So we have here our episodes. There are some things you need to learn. But what really stands out is that everything is a function. So we are not saying export class, something component, but it is a function that generates a component. This is the first thing. And the second one is that all these functions have this $sign. And this is a sign for Quick, that it can lazy load this function. So this is where it comes from. So every function more or less could be theoretically be lazy loaded. So during the bundling, it creates all these tiny JavaScript files, and then it just loads them on demand when I click on something. And we see this. First of all, let me show you the network. So we have here 800 kilobyte. Again, this is the most comes from my Chrome extensions, because if you look at what's really loaded from the server itself, it's just 80 kilobyte. It's not much. But if I click on something, like the edit button, then you see that now loading happens. It just starts downloading something more. And if I remove this and I do another action like cancel, Then I'm loading other JavaScript files, and they're all very tiny. So they're just 1 to 2 kilobytes. And Quick, of course, can also defer this. So you can say, yes, when the application starts already, I can already send the JavaScript files to the client. Then they are already there. But it's not necessary. The application will still work. Yeah. And as I said, this is more or less what we currently have. And the question actually for me is, what should we do? Should we stay with our existing frameworks? Should we move on to something else? Or what should we want to, what should we do? Looking at the statistics, we have to say that there is a huge difference between reality and perception. If you ask developers what they want to work with, it's very likely that they will not tell you React, Angular, or Vue. But this is here, these are the responses or the results of a survey done in the beginning of this year. Most of them say Svelte, Solid, these are just cool technologies. Yes, Vue comes afterwards, but if you take a look at Angular, for example, I would definitely have to say I need to find a new job because it's over. But as I said, this is just a perception. If you look at the statistics, it looks differently. Here we have the download statistics for Quick, Astro, and Solid.js. Solid.js, remember, is one of the most popular, most wanted frameworks at the moment. I didn't mention it because it's cool, but the other ones were more important in terms of hydration and all that stuff. But you say, okay, looks good. Astro and Solid.js are really taking off. But if you then add Svelte to the same chart, you see Svelte is in a completely different dimension. And if you're saying, okay, and now what about the big three with for example, with Angular and Vue? If you add them, it looks like this. And then these great frameworks like Quick, you don't even see them anymore because they are not, because the majority is still working with Vue and Angular. And it gets even worse or better, depending what you're doing, when you add React. So React is far away from everything else. You can even call it as a standard, but nevertheless, you see there are still these three major frameworks. And what I think, what should we do? I have to say there is experience I made in the very early 2000 years, 2005 or so. There was this book Beyond Java, where they said, well, Java is dead, forget it, you don't need it anymore. Of course, very well researched, so it really made sense, but it didn't end like this. I mean, we all know this, because otherwise this wouldn't be a Java conference anymore. And the reason why this is the case is, and this is something that the Angular team always says quite often, the existing frameworks, they have solutions for all use cases. So when you need something, when you have interactive or complex forms, when you want to have a PWA, or when you want to do anything, it's very likely that your framework, the big ones, have a solution for that. The newcomers, they excel only, or they just show you the need spot. They say, okay, this is where we are very good in, but if you, for example, take a look how the form support in Quick looks like, you would be disappointed, I would say, a little bit. And because of that, we have a situation where the frameworks have some time. So the big ones, they can afford themselves to take a look what the others are doing. They can wait if it is really a hype or if it is really something new that comes. And then they also have the time and the tools available to integrate these new features into their own framework so that it really fits. So they don't need to stress themselves. They have the time to do this. The only question for me is, and I look here very particular to Quick, if it's actually possible in a technical way, because this is what we always hear from Quick, but also from the other frameworks, to be fair, for example, from Angular. In order to come up with this technology that Quick has, there is such a huge undertaking required to rewrite the framework that it's really hard, let's say it like this. And this is the main question for the future. If the big three can really, or have the possibilities, or want to change, want to rewrite parts of their systems, or not. I think that's it. But for the moment, I would say it's just quite safe, if as you have seen from the statistics, to stay with these frameworks, so you don't need to rewrite your application tomorrow if you are on Angular. Please don't do it. Angular is also looking into these hydration things, and they have already promised to do something next year, but it will not be in that dimension as Quick does it. Last but not least, I have 6 minutes left. I really challenge this notion that everything must be faster. Yes, of course, it's good if everything is faster. I also want to have my applications faster, but the question is, should the frameworks focus all their energy on that? And when I started programming, it was like this. You had an application, so their web applications didn't exist. But when it was a small application, you used Microsoft Access with their form builder wizard. And if you had a huger one, then you went with Oracle Forms or used Delphi. It was very easy compared to the applications that we write today. Now, we have to say the web adds, of course, some additional complexity. Yes, that's all true. But nevertheless, we have to see 20 years have gone by. And if we take a look at the amount of code or the complexity that we need to put into writing very similar application, I would say maybe don't spend so much time on speed or improvement. Maybe try to improve the developer experience. Try to make the framework better usable. I don't want to write so many code. I want to have that. I would really much appreciate it if I don't have to write so much code for a normal form that gets some data and sends it back to the server. So this is what I think is also very important. And luckily for us Angular developers, this is what the Angular team also says. So they say, okay, we're focusing on developer experience. That's quite good. But in the end, it will show what is more important if this really takes off, this on-demand hydration, or how Quick calls it, resumability. That's the correct term, actually. Everybody has to follow because every developer wants to work with it. This is just this hype-driven development that we are in. But that's more or less it. So just something to think about at the end. From the summary, we will see that tools will be replaced by languages, not JavaScript, by Go or Rust. I would be really surprised if that's not the case. JavaScript will still stay. We will still write JavaScript in the upcoming years, or TypeScript. Zero-size framework, very interesting. I very much like the idea of Svelte. I don't know why the other frameworks don't do it like this, because it's a significant reduction of the bundle size. And in the end, and this is the main message, we will see that more and more code, JavaScript, will run in the backend. So we are going back to the backend. And this is actually why I named my talk Back to the Future. Because it's more or less backend involved. 3 minutes left. I think we have time for some questions before we start that. I want to say thank you for attending my talk. And now let's come to the questions.